Hello and welcome to everyone in physicsfire. Today we are going to do the sixth part of class of current electricity, not class of current electricity of sixth part. And then here we are going to do some complex circuits of what symmetric circuits of current electricity. Last class we had done about Wheatstone bridge as well as few numericals also on the basis of series parallel questions, right? So today's class, we are going to do what? Symmetric circuits. You will see like 10 resistance are there, 15 resistance are there, but you guys can solve it very fast with a lightning speed in 10, like 40 seconds, 30 seconds, in 30 seconds even you can solve if you'll understand this concept properly. So two types of symmetries are there. One is folding symmetry as well as what? A mirror symmetry. So let's see, first we are going to understand here what is mirror symmetry and what is folding symmetry. So yes, the photo should be a big little, right, so that you can see it properly. Okay, so first we are going to see here the mirror symmetry. Let's see now. Now let's take it as R, 2R, 2R. This is R and this is R. And this is B. So now you are supposed to find what? Mirror symmetry. Let's see a symmetry, not directly I am saying the mirror symmetry now. So if you'll see here one thing, that if you put a mirror here, if you keep a mirror here, let's consider this red color line is a mirror. Have you ever seen red color mirror? Yes, this is the mirror of red color, right? So now if you will put a mirror of red color, keep a mirror of red color, this is 2R. Of course, this is also 2R, right? If this is R, so this will also be what? R. So this is R, that is also R. Again R, R, right? So if you keep a mirror there, then RR, 2R, 2R, RR, right? Fine. So exactly you got the same image, right? 2R, R, 2R, R. It means what? It is a mirror symmetry. It is what here? Mirror symmetry. Another way, what we can say, suppose current I is flowing here, right? So here, let's consider I1 is going, and here it is going what? I2, right? So finally, what will happen? All the way, it will go in this direction. And then finally, you will get here current as what? I1 here. And then here also what? I2, and come out same current. Right? So this types of symmetry is known as what? Mirror symmetry. Mirror symmetry. Got it? That is what? Mirror symmetry. Another type of symmetry is also there. Let's see now. That symmetry is what? Suppose right? So this is A and this is what? B. Now here, this is R, this is 2R, this is R, and this is 2R, right? If you will do a mirror, if you keep a mirror of not red color now, of let's take black color, right? If you put this black color mirror, it is not going to be the same. This is R, so this is 2R. R, 2R. No, it is not a mirror symmetry. So another symmetry is there, right? We cannot do by mirror symmetry, right? Another symmetry we can say here, can use here. This is what here? folding symmetry across A and B. Across what? A and B. So it is a folding symmetry. If you'll fold it, R, 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 R. So here what is going to be, suppose this point is X, so this point is also what? X, means we can say the voltage same. Y, Y, Z, Z, right? So X, X, these two are in parallel, right? So obviously same voltage, parallel, same voltage, parallel, same voltage. So here Y, Y, right? Here is what? Y, Y. So what will happen now here? You will see Y and Y. So this resistance between what? X and Y. This resistance also what? X and Y, right? This resistance also, this resistance is in Y and Z. This resistance also what? Y and Z. But this resistance is what? Y and Y. So no point of writing that resistance. So it is not there at all, right? So these two resistance are in series. No need. Directly you can do even. So these two are in parallel. You can solve it now. How? So we can say R and 2R, right? R and R. So it is going to be what? R by 2. R by 2, right? Folding, no? This time folded. It is parallel to it. And then another is what? 2R, 2R. It becomes parallel. So this resistance is not there at all, right? Because it is in between the same point, A and Y, we cannot write it. So this A, this is what B. So you can solve it. So by this way, we are supposed to apply what? Mirror symmetry as well as what? Folding symmetry. Let's see now a few questions now. The first question which is going to come here, that is, right? So, and another is what? Correct. Now let's consider all are R. All are what? R. They are asking find equivalent resistance between what? A and B. Find equivalent resistance between A and B. Folding symmetry, if you will see, that should be like this, right? But we cannot apply where how you will fold. From A and B, you cannot fold, right? So you'll have to apply here what? Mirroring symmetry. So if you'll see mirror symmetry, RR, 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 right? RR, right? So we can say now, if you are applying here mirror symmetry, then let's consider here is I1 and here is what? I2 and here is I is splitting into what? I1, I2. So ultimately what will happen as this is R, so this is also going to be R, this is R, so this is R, right? This is also R. So we can say here it is ultimately it will come like this is what? I2 and this is what? I1, right? So it is going to be the same. So what is done? If it is I1, this is also I1. So there is no point of this point. So lift it up, right? Because there is no junction at all, right? So it is like this now. Yes. Okay. And then yes. So now it becomes easy. This is A and this is what? B. So this R and R becomes what here? 2R. Right? This R and R again 2R series. R, 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 R. So now we can say this 2R becomes 2R, right? R and R. This 2R becomes what? Again 2R. And this 2R becomes what? 2R. Fine. So this 2R, and after that, what will happen? See this and this. Okay, this 2R and this 2R, this 2, this up, this thing, and this. So it becomes what? R and 2R and 2R. 2R is in parallel. So 4R square multiplication by addition So 4r square divided by what? 4r square divided by 4r. So it becomes what? R. So now we can say yes, it is what? R only. Then R, and that R, right? Which R you guys understood, right? This two equation, right? So you will get what in series. So we can say R, R, R. So all are what? R. After that, what? Again in parallel. This is A and this is what? B. So 3R and 2R is in parallel, right? So how much it is? 6R by what? 5R. 6R square by 5. So 6 by 5 is the equivalent resistance between A and B. Yes. So this was what? Mirror symmetry. Now solve it again by folding symmetry. Let's see this question now. Right. So now you are supposed to find equivalent resistance between what? A and B. Equivalent resistance between what? A and B. Equivalent resistance between what? A and B. Let's see now how we'll find equivalent resistance. R, 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 R. Hey, double R we gave there. This R, R, R. So remove this. One R is already enough, not two R's. So here is one more R. So now let's see, we are supposed to solve it by what? Folding symmetry. So folding symmetry, if you will take here, we can solve by this way, right? Let's fold it. So if this will go here, it will become R by 2, R by 2, right? R by 2, R by 2, R by 2, R by 2, right? So what is happening here exactly? If you are considering, let's consider this is X, this is X, this is Y, this point is also Y, this is Z, this is what? Z. So this resistance between XY, XY, this resistance between what? YZ, YZ, this resistance between what? We can say here, AX, what is that? XA, right? Like that, fine. After that, what? Let's consider this is O, right? This is what here? O. So we can say OZ, OX, right? So like that we can write. So ultimately now the point here is what? We can say here what? This is OX, OX, right? So parallel again. So that will go here. OZ, OZ, right? So by that way, we can say yes, everything is in what? Parallel. So there is no point of this, right? This point, right? So directly what we can do, we can voltage is same. See, X, X. So same only, right? So we can say now here. So we can lift it up, right? Voltage is same across this point, like OXO, OX, OZ, OZ. So what is the point of that thing, right? That junction, there is no point of that, same it is. Fine, now we can say everything is in parallel. So RR becomes what? R by 2. And this also becomes what? R by 2. And then what? This also becomes R by 2. This also becomes R by 2. This also becomes R by 2, R by 2, and R by 2. Right? That's it now. Now we can, now you guys can solve it, right? We'll solve it later. We'll get an answer. Fine. How much it will come? It will come as like array. Now you can solve no R. So it become R by 2, R by 2, R by 2, R by 2. So 3R by 2. What is this? Easily you can solve after that, right? Let's see another question now. Another question is what? Yes, this is the question. This is A, this is B, this is R, 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 R. Now we are supposed to find what? Equivalent resistance. Let's see if you'll take a folding symmetry. Can we take like we can do by folding also, we can do by mirror also. So let's practice for mirror. So mirror, if you will see here, let's put a red color mirror like this. If you'll put a mirror here, R, 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 right? That's it. Now we can say here what? So what is the use of this tool? No use. Even by Wheatstone bridge also you can say one small thing. I'll say R, 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 R. It is a balanced Wheatstone bridge, no current free flow. R, 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 no current free flow. Yes. So we can say anyway by Wheatstone bridge also, not Wheatstone bridge, by folding mirror symmetry also, we can say that what? There is no point of writing that. So we can say now here what we can say, suppose current is flowing I here, I1, here is what? I2, and here is what? I3. So ultimately here like with battery is there, no? So I1, I2, I3. So ultimately there is no point of writing this register. So we can do like two registers are there, right? That's it. Now these two are in series, these two are in series, these two are in series. So R by 2, R by 2, R by 2. So R by 2, R by 2, R by 2. How much it will be? R by 2 plus R by 2 plus what? R by 2. That is R by 2. So if you solve it, R equivalent to R by 3 will come, right? When you solve it, all are in parallel. That's it. Now let's see the next question. Next question is what? I'll write in a simple way. Yes. So there is a resistance, guys. There is a another resistance. There is another resistance, and then one more resistance. One more resistance here. Fine. You are supposed to find. We are supposed to find what here? We are supposed to find between A and B. Find equivalent resistance between what? A and B. Find equivalent resistance between what? A and B. It's not looking good. Fine. Anyway, doesn't matter, right? Let's see now how between A and B. So we cannot do by what? Mirror symmetry, right? Or mirror, how we put. So let's apply what here? Folding symmetry, like this. So if you apply folding symmetry, then R, 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 right? So everything is in what? We can fold it easily, right? So let's see now, if you apply folding symmetry here, so what is going to happen? This becomes what? R by 2. So ultimately it becomes as what? Like this. I'll draw like this directly, and I'll draw it later. A, B, right? Let's take a color. This one register here, of course, one registers, one more, one more. So this and this R by 2. This and this inner one R by 2. This and this R by 2. This is not R by 2. Remember that there is no pair, right? So only R, correct? So this all three are in what? Series. Acha, what will happen to this? It is same, no? If you will take, suppose, let's consider, what is that? Let's consider this is Y, right? And this is X, right? And so this is Y, so this will also be Y. This is X, so this will be X, right? So this is what between YX, this is also between what? YX. So XX, XX, so no point of writing this. That's it. Understood? So it is not possible, right? Voltage, how we can write that? We cannot write. Can we write in between the 1 point a register? No. So that's why there is no point of writing that XX between there is a register. Fine. These two are in what? 3 are in series R by 2, R by 2, R by 2. So 3 R by 2 and then R is in what? Series parallel. Then you can solve it. That's it. That was about what? To solve by folding symmetry. Now, again, let's see one more question here. Right. So we can say here A and what B. Find equivalent resistance between A and B. Find what? Equivalent resistance between what? A and B. Find equivalent resistance between A and B. Let's consider, suppose current is starting from here. Let's consider this is I1, this is what? I2, this is, acha, which symmetry you will apply? All are R. So you cannot apply. How you will apply folding symmetry? You cannot fold between A and B. So only one option is there, that is what? Mirror. Black color mirror you put. R. Hey, where is this resistance should be somewhere here, right? That will be easy, no? R, right? By that way, we can say yes, it is a mirror symmetry, right? Same what is coming. So mirror symmetry. So fine. So we can say here now I3 and this is what I1 and I2. So ultimately we are getting here as what as it is a mirror symmetry. So it is coming back here, here and here. So it is coming how much? I3 and this is coming how much? I2 and this is what? I1. So what is the point of this junction? There is no point, right? So lift karado, right? Little to lift it. Right now we can say here yes. So yes, by that we can solve it, right? So now these two are in series. Again, these two are in series. These two are in series. These two are in series. Solve it. I'm not going to solve now. So till here we will solve the series parallel sums, like complex circuits. Next class we'll do another topic. Here, hope so you guys understood. Revise it properly. If you have any book, like from other books also, you solve more numericals. Okay, we'll see in the next class.